So let's start with the seminar. So my seminar topics are this. These are the contents, that is Mac security, Hmac security, DAA, CCM, GCM. So we will see what are these things. First, let's know what is Mac security. So Mac security, as we know, we have heard about the Mac security not over only in information security, in networking. In networking we have encountered with the Mac security. So let's start with the Mac security. Message authentication codes. These are the full form of Mac. Message authentication codes are the codes which plays their role in two important functions: authentication detection and falsification detection. Authentication detection is a type of detection when a real-time user is accessing or authenticizing with the data. So that is called an authentication detection. Falsification detection has many roles in it. Let's see an example and then we can understand what is authentication detection and falsification detection. So suppose user A has want to send a message to user B. So that message is A B C. A encrypts the message using shared key crypto system. This is the component used shared key crypto system because the same key is being shared to the sender is sharing the same key to the receiver, right? So for the encrypting of the message, A sends the key to B using a source key. Key exchange is based on different protocols such as public key. We know that many protocols we have studied like public, private, protected. Now when it is confidential, then it comes the secured or the encrypted or secured source key or secured key crypto system. So let's see, if A has a message called ABC and it wants that message to be passed over to the B through a public key crypto system, or you can say shared key crypto system. So the A has one key and B has one key. So if A key, the key that A has matches with the B, then only the message will be passed. So that is known as authentication detection. Means the keys are the same and both the keys have been matched. Then only the message passes from A to B. So now the falsification detection comes into the phase. That is, if A has a key that doesn't match with the B, so that is a false key over representing over here. So that is called a falsification detection. Okay, that is called a falsification detection, or any kind of interruption happening in the detection, and when it leads to a error or a fault or a fail, then it is known as a falsification detection in Mac security. So let's go to the next topic, that is Hmac. Now what is the Hmac? Hash based message authentication code. So just to give you a small idea, in Linux we have studied about password and shadow password, right? So password is just storing the password, that is normal characteristics password, and the shadow password stores the hash password because it has been encrypted. So the same, just a small likely concept is over here, that is, it is a type of a message authentication code that is acquired by executing a cryptographic hash function on the data to be authenticated and a secret shared key. Like I said before, it was public shared key. Now it is secret shared key. Like any of the Mac, it is used for both data integrity and authentication. You have to maintain the data integrity and at the same time authentication has to be given. Checking data integrity is necessary for the parties involved in the communication. So these parties are nothing but the protocols such as HTTPS, SFTP, FTPS, and other transport protocols like protocols use Hmac. The cryptographic hash function may be, these are the kind of hash functions such as MD5 that is using security, SHA-1 or SHA-1, SHA-56. These are the kind of encryption hash functions that are used over the Hmac. Digital signatures are similar to Hmacs. They both employ a hash function and a shared key. Now in Hmac, what we use is same key. The receiver and the sender has the same key and it matches. Now in signature, they have two different key but it matches. So this is the kind of property that Hmac shows. Now what are the applications of Hmac? Verification of email address during activation or creation of an account. This is the first application of the Hmac. Authentication of form data that is sent to the client browser and then submitted back. Hmac can be used for the IoT, mainly you can see that in Raspberry Pi, because Raspberry Pi uses HMAC in a huge, huge amount, as it is, for example, let's say like in Raspberry SPI using camera, so it uses HMAC for the data authentication and cryptography also. In that, SHA 256 is used. Whenever there is a need to reset the password, a link that can be used once is sent without adding a server state. And it can take any message of length, like a long message also it can take, not a problem. It is a fixed length message digest. Now the message digest, what does it, like we see in WhatsApp notifications that we get to see a starting of the message, right? And we get to know that what the message is about. Same here, the message digest takes the message, it takes in the short form, it displays to you so that you get an idea of what the message is, but in a secure, secret, shared key. Now the HMAC is over. Let's go to DAA, sorry, data authentication algorithm. Now, not only in just information security, DAA is used everywhere in networking, in DBMS, everywhere, because authentication comes into the play everywhere in the computer science. So let's see what is DAA. The data authentication algorithm, or a DAA, is widely used Mac based DES, data encryption standard cipher, and using CBC mode. Although it is now considered obsolete, first let's recap the cipher block chaining, that is the CBC, or the CBC mode for the block cipher operations. Now, the figure has not been put here, so let's say DAA built on such block cipher operation mode and uses DES for the encryption blocks with 64 input, and these are just the the writing explanation of what DAA is. Data authentication algorithm is any data that is passed through an authentication has its certain algorithm built inside it, so that the sender and the receiver gets the same data and the data is not tampered with, right? For example, if I am sending hello to one of my friend, so when I send that message from this end, the other end, or the front end, where I am sending the message, the destination should not receive a message that I have not sent. For example, if I am sending hello, so he should also get hello. If I am sending hello, he should not get hi, right? So this kind of things data authentication algorithm uses, so that the message can't be tampered with. Okay, so these are the normally 64 and K is 56-bit long here. So these are just the technical terms that are used in data authentication algorithm. Okay, so the last block of PVN, or the private network message, is zero padding if needed. Means it has zero padding. That has that means the message cannot be changed at the destination mode. Right? If I am sending a message from the user end to the receiver end, so the message could not be changed once it has reached the destination. That is called zero padding. Okay. So DAA, not only we have seen a number of ages that DAA has been in the phase. So now let's go to the next topic, that is CCM, counter cipher message. Now counter cipher message blockchaining message authentication code, CBC Mac, is a mode of operation for cryptographic block ciphers. So every ciphers has its own property, right? So this cryptographic block cipher also has its own property. So to overcome that is called the counter cipher message. Okay, so if any message that we are sending to the cryptography, we know that it will be secure. So the counter cipher message, what does it do is it creates a block type of grouping system in that message cipher, so that the operation for the cryptographic block ciphers are done with ease. It does not complicate things. So CCM mode is only defined for the block ciphers with a block length of 128 bits. The max length of the block is 128 bits. Okay, so the nuance of the CCM must be carefully chosen to never be used for more than one given key. One key, one at a time. So that one key cannot be used repeatedly. This is because CCM is a derivation of CTR mode, and the latter is effectively a stream cipher. Okay. So as the CCM mode combines well-known CBC, as I told before, CBC Mac with the well-known counter mode of encryption. These two primitives are applied in authenticate the encrypt. First, you have to authenticate the message, right? If the message is truly an authenticized or it is a real message, then you have to encrypt in a manner. Like for the first stage, you get a message. Second, you authenticize the message. Third, then you encrypt it, right? So that is the CVC MAC is first computed on the message to obtain a tag. The message and the tag are then encrypted using counter mode. So this counter mode, the message and the tag are encrypted. Okay. The main insight is that the same encryption key can be used in both, provided that the counter values is used in encryption that do not collide with the pre-initialization vector used in authentication. So the CBC MAC and the CCM, the CBC MAC that we used priorly, and the CCM. As we know that CCM is a derivation of CTR. So the nuance of the CCM, as we said, we have to carefully choose, right? Because it has a certain block length of 128 bits, right? So if it extends that, then the pre-initialization won't happen and the vector authentication won't also happen. So the proof also applies to a generalization of CCM for any size of block cipher and for any size cryptographically strong pseudo-random function. So this kind of pseudo-random function can be used throughout the counter cipher message, because from the start to the end, the counter cipher message from the start, from receiving a message to authenticating, then encrypting, then creating a counter cipher message block, then cryptography block of it with a certain length of 128 bits. So this is the counter cipher message. Now next comes the GCM, Galois counter mode. In cryptography, Galois counter mode is a mode of operation for symmetric key cryptographic block ciphers. As I said, there are two: symmetric and asymmetric. Asymmetric, two different keys; symmetric, same keys, which is widely adopted for its performance. GCM throughput rates for state-of-the-art high-speed communication channels can be achieved with inexpensive hardware resources. The operation is an authenticized encryption algorithm designed to provide to both data authenticity, integrity, and confidentiality. Now, with more confidentiality comes the more encryption standard. So the Galois counter mode is a mode of a symmetric key. Here the asymmetric key doesn't come to the face, as the symmetric key does its work. Right? Both has the same key in the cryptographic block ciphers. Okay. So let's see what it is. Galois message authentication code is an authentication only variant of GCM. Only authentication parts this Galois counter mode works on, right? As I said before, you get a message, you authenticize it, then you can encrypt it, right? For encryption, we have DES, AES, this kind of security we have: AES, active encryption standard, and the DES, data encryption standard. Okay, so both GCM and GMAC can accept initialization vectors of arbitrary length. Before it was 128, right? Yes, so here it is also 128. Different block ciphers of operation can have significantly different performance and efficiency. For example, every cipher modes, right? For example, if I say that one cipher mode has a ability to get 128, right, and the other cipher block has the ability to get only 32 bits. So which will perform more? The 128 one. Which will take the load more? The 128 one. Which will do the faster thing? 32 one, right? So each and every cipher block has its own advantage and own disadvantage, right? Because the 32 block will complete the operations faster because it does not have more load. The 128 bit has the more load. Okay, so each block of cipher modes have significantly different performance and efficiency. Not only 32 but also 28. So both are excelling in their own own para. By contrast, the cipher block chaining mode of operation incurs pipeline stalls that hamper its efficiency and performance. Now what happens is, this cipher block chaining mode of operation incurs pipeline stalls. Pipeline stall means, for example, if the data is passing or the message is passing, it has an order, right? In a pipeline stalls, it in order it passes through the from the receiver, from the sender to the receiver. So this pipeline stalls that tamper with the speed or tamper with the message can result in less efficiency and less performance, right? Or if, for example, if the message has changed in between, so it will affect its complete performance because the message has been changed, the message has been tampered with. So this kind of things are also a disadvantage of the GCM. Galois counter mode. Thank you.